let us discuss motion of connected bodies. The meaning of motion of connected bodies is that there can be so many bodies, one or two bodies, which are connected either by strings or springs, and a force is applied on them, and we are going to study how they move and what is the acceleration of each particle or the acceleration of the system is. Basically what we use here is our basic idea about second law of motion. From second law of motion we know that the force acting on a body or a system F gives the acceleration on the system, and that relation is given by F is equal to m times A. We understand that F is a vector. We also know that acceleration is a vector, but mass is a scalar quantity. So the direction of acceleration must be along the direction of this applied force. So that means a force will produce an acceleration in its own direction. If there are so many forces acting, a large number of forces acting on a system simultaneously, then the acceleration will be along the direction of the net force acting on it. How do we find the net force acting on a system? Nothing. We use a vector addition of different forces. Let us try one system where many forces are applied or many forces are acting. Consider a surface. Consider a surface. Assume that this is a smooth surface. Means this is frictionless. Practically not a possible thing, but we'll assume that there is no friction. It's a slippery surface. Consider a block of mass, say 5 kilogram. There is a block of mass 5 kilogram, and a force is acting on it. Let us say the force has got a magnitude of 10 Newton. We are going to find out the acceleration of the block. Okay. First of all, let us find out which are the different forces acting on the system. How many forces are acting on the system? Of course, we know that there is a 10 Newton applied force which is trying to pull it. Are there any other forces? Yes, of course. One force is nothing but the force of gravity. We call it as weight of the body. Weight is generally marked vertically downward because we assume that it is acting towards the center of the earth, and the weight of a body, W, is written as m into g, where m is the mass and g is the acceleration due to gravity. For easiness of calculation, let us take the value of g as 10 meter per second squared. So what is the weight acting downward? The weight acting downward is 5 times 10, which is nothing but 50 Newton. But we know that from the solid surface there will be a force acting perpendicular upward, which is called the normal reaction. How will you mark normal reaction? It will be exactly opposite to the weight of the body. So this is where we mark normal reaction. If you place a body on a surface, the body doesn't go down. It doesn't sink to the surface or doesn't go upward. So what does it mean? This n and mg must be equal in magnitude but opposite in direction. We can actually feel that there is a pull downward of 50 Newton and there is a pull upward which is also equal to 50 Newton. So we can say that n is equal to 50 Newton. Now tell me, how many forces are acting? There are 3 forces. One, the weight acts downward. Second one, the normal reaction upward. And the third one is the applied force. Assume for a moment what would happen if you did not apply the applied force. A body kept on a surface, just like this. Does it move? It doesn't. Means there is no net force acting on it. Weight is balancing the normal reaction. So these two forces cannot produce motion in the body. The motion is produced only by this 10 Newton. Let us calculate the total force acting on the system. The total force acting on the system, I can write F total, which is a vector, which is nothing but F, the force of weight of the body, plus the force which you call as the normal reaction, plus the applied force, Fa. we know these two forces. We can say that the force of weight is equal to negative of force of Newton because they are in the opposite direction. So that cancel each other. So the net force acting on the system, F total, is simply the applied force Fa. So what will be the acceleration of the system? We know acceleration is nothing but the applied force, which is the total force divided by the mass. If you take the magnitude of acceleration, let us say the magnitude of acceleration is A, which is nothing but the magnitude of the applied force divided by mass. What is the magnitude of the applied force? That is 10 Newton. What is the mass of the body? It is 5 kilogram. And this gives you an acceleration of 2 meter per second square. And what is its direction? Of course, the body will have an acceleration in that direction. Finally, the body would move in this direction with an acceleration equal to 2 meter per second square. This is one example. This is actually a pretty simple example because we consider only one applied force and there is only one body acting, one body where force is acting. What will happen if there are multiple bodies connected together? Let us try another one. Bodies can be connected together by using strings, and the strings that we consider here are massless. Practically we don't have strings without mass, but we consider that the strings here are so their mass is very negligible compared to the other masses considered. Okay, let us keep in mind that second law is used in all these calculations. And what is second law? Second law tells you there is an equation for force, F is equal to m into A. You are probably thorough with that idea that the force will produce an acceleration along its direction. Again consider, this is again I'll say we are in the beginning stages, so we consider again a smooth surface. I can say the friction is absent here. There is a body connected here, placed there. There is another body. Let us take the mass to be 2 kilogram and this mass say 3 kilogram. Two bodies. Let us assume that this is connected by a string. What kind of a string is that? It is a massless one. It is massless. Moreover, it cannot be extended. It cannot be elongated. So we call it as inextensible. It is an inextensible string. That means the length between, the distance between the two blocks, so the length of the string remains constant, whatever be the force acting on it. Let us try a force applied here. Let us say it is 10 Newton. We have already seen in the previous problem that weight of this body will be cancelling its normal reaction. Here again weight and normal reaction cancel each other. So the only force acting on the body is 10 Newton. What will happen to the system? Definitely the string produces a force which is called as tension. And that you can see that. See like this. Think for a moment that what will happen, like you are pulling it in this direction. When you pull it in this direction, the distance between the two bodies cannot increase. This is not a rubber band or a spring. Naturally, if this moves 1 meter forward, this must also move 1 meter forward. Right? So at any moment, the velocity of these two bodies must be identical. If this changes its velocity, so this will also. So their acceleration at any instant must be the same in magnitude and direction. So we can say that there is an acceleration here, A, direction and magnitude, then this must also have the same acceleration in the same direction. Very easy. Now tell me, if I cut the string, what will happen to this body? Definitely we know that will stop. So the string applies a force on the block. Without that force, the second body cannot move. The first body will anyway move because it's applied by a force of 10 Newton. So there is a force in the string. And how will I mark the direction of that force? I will mark, and that force is called tension. The tension is pulling the second body forward. So that can be marked. There is a force on the 2 kilogram is in the forward direction. Think again that what will happen if I cut this one? What will happen to the motion of this 3 kilogram? If I cut that one, we know that this can move easily. There is an easiness. So why is that easiness? Because this body is actually a load on the first body. It's actually pulling it backward. So the same string will apply a force on the 3 kilogram in the reverse direction. So this is how we mark the direction of tension in the string. Now, what is the net force acting on this body? The net force acting on this body is nothing but tension. Okay, so if I do that, if I take that body here separately, if I consider it separately, there is this 2 kilogram, this is 2 kilogram, and the force acting on it is T. The other forces are cancelled. Its mass is given, tension is there. So definitely I can say, I can just remember that F is equal to m into A, then net force is equal to m into A, and the force here is nothing but T, and that should become 2 times the acceleration. Call it as equation 1. We call this as free body diagram. What is it called? Free body diagram, or in short I will write it is FBD of this 2 kilogram. Similarly, I can draw FBD, that is a free body diagram of 3 kilogram. How will I do that? Just see. This is the 3 kilogram block. This is the surface. Is there a force acting on it? Yes, and that is 10 Newton in the forward direction. Is there another force acting on it? Yeah. Which one? The tension which is pulling it backward. Still, we have taken that it is accelerating in the forward direction. So, tell me, if a body is accelerating in that direction and if there are 2 forces acting on it, which force must be stronger? Definitely 10 Newton is stronger. So what is the net force acting on it? The net force in the previous case was tension, but here this is T, it is 10 minus T. That is the net force. 10 in that direction, T in the next opposite direction. So net force must become 10 in that direction, and that is responsible for the acceleration of this 3 kilogram 3A. Call it as equation 2. Add them. Add the equation 1 and 2. If you add the equation 1 and 2, what you get is 10 minus T plus T will give you 10 equal to 3 plus 2 will give you 5A, and which implies that acceleration is nothing but 10 by 5, it is 2 meter per second square. So this will accelerate at the rate of 2 meter per second square. This will also accelerate at 2 meter per second square. So we got the acceleration of the system. See, in examinations, sometimes questions can be twisted, and very small twist can confuse a student. In total, they will ask you what is the acceleration of the system. We see the system has the common acceleration. Let's see, sometimes they will cunningly ask you what is the acceleration of the 2 kilogram body. Students might think that the acceleration is different for the 2 different bodies, and we know that it is not the same. I mean, it is not the case. The acceleration is same for both of them. Right. Tell me what is the force acting in the string, that is the tension in the string. How much is the force acting in the string? You can, to get that answer, you get directly go here in the equation 1. T equal to 2 times A. And what is A? A equal to 2. So substituting will get T equal to 2 into 2, 4 Newton. So 4 Newton is acting in the string, and which is trying to pull this 2 kilogram body. That is one case where there are 2 connected bodies. There can be more problems on connected bodies with friction, which can become little complicated. Okay, we'll take up a very simple one first. A simple problem where friction also acts. Friction, we studied about friction, that to move a body, we need to overcome the friction between the body and the surface. Let us consider a surface here, and say there is a body of mass 2 kilogram. We take 2 kilogram, 4 kilogram, etc. for easiness of calculation, but this is applicable for any force. So let us say there is a force, horizontal force 10 Newton, and it is given that mu equal to 0.2. What is the meaning of mu equal to 0.2? Mu is called as the coefficient of friction. Coefficient of friction between the block and the surface. Okay. What is the frictional force acting between the body? See, the frictional force acting between the body can take any value between 0 to mu times mg here. 0 is the minimum and mu mg is the maximum. What is the maximum friction here? Let us calculate the maximum friction. We can write here the friction which is maximum equal to 0.2 times say mass is 2 kilogram and we know that, and say g is equal to 10, so this will give you 10 times 0.2 into 2 is equal to 4 Newton. So what does it mean to us? 4 Newton. It means that to move this body at least 4 Newton of force horizontally must be applied. Okay, so we know that the force acting is 10 Newton, much larger than that 4 Newton required to move the body. Okay, so we can mark friction in the backward direction, even though it is acting between the surfaces. I can mark it backward, and that is 4 Newton. Right. So what is the net force acting on the system? I can say the total force on the system is nothing but 10 minus 4, which is nothing but 6 Newton. So this is the 6 Newton which is going to accelerate the body. So we can say, use the equation A is equal to F divided by M. We'll get a 6 Newton is a force and 2 kilogram is a mass. So the acceleration here will become 3 meter per second square. So 3 different problems. Please work out them. You will get the basic concepts in motion where we can find out acceleration. That is a very simple beginning, but this can take you to heights. Thank you.